When we're doing calculations, we need to be using significant figures in all the calculations. And so there's some rules that go with significant figures in calculations. And the first rule is a rule for multiplication and division. And the rule that we're going to use is that we take whatever significant figures we have in our calculation, the ones that are measured. Of course, we don't use exact or counted insignificant figures. And so what we do is we go by the least number of sig figs. And so what you have to do is after you set up a problem, you have to go through and you have to count however many significant figures each number has, and then you take whatever you have the least of, and that's what your answer is going to be. And so I want to point out up here is that the purpose of significant figures in calculations is to correct your calculator answer. Now, so how is that going to work? So let's say we have this calculation right here. So we have, say, 11 times 233. And I'm going to put that in my calculator and see what I get. So I have, say, 11 times 233, and that's 2,563. That's my calculator answer. 2563 is my calculator answer. Okay? So now we look at it and we say, well, 11, let's see, that's 1, 2. So this is 2 significant figures. 233 is 3 significant figures. And so if we look, we see 2 and 3, and 2 is the least out of those two. And so our answer should be 2SF. Now, right now, 2563 is 4SF. And so what do? And so what we do is we go across and we go 1, 2. We're going to look one more over. And if the number is 5 or greater than 5, we round up. And if it's 4 or less, then we drop. So we see that we have 2, 5, 6, 3. We go 1, 2. We look at the 6. We say 6 is 5 or greater. And so we need to round up. So that 5 is going to round up to a 6. And so we go 2, 6. Now we have to keep it the same size because 2563 is 2,000 and some change. And so we need to add placeholder zeros to keep it the same size. So we added placeholder zeros to keep that number the same size. It's a common mistake to take your 2563 and you want to round it to 2 sig figs and just say, well, it's 26. Well, 26 is not the same as 2500. Okay, so we have to add placeholders on there. So let's try another one. So how about we have, let's say, 15.2, and we're going to divide by, let's say, 4.649. And I'm going to put that in my calculator as well. And I have 15.2, and I'm going to divide by 4.649. And I get a calculator answer of 3.269520 and some extra digits. And there's a whole bunch of digits that are on my calculator. And so we have to round this to have the correct significant figures in our calculator answer. And we look at the 15.2 when we go 1, 2, 3. So this is 3 SF, 3 significant figures. And I look at the 4.649, and that's 1, 2, 3, 4. That is 4 significant figures. And so the least between 3 and 4 is 3. So this should be 3SF for our calculator answer. And so we have to go ahead and count and try to decide, well, where is 3 significant figures? So we start here, we go 1, 2, 3, and we're going to look one more over, and 9 is 5 or greater, and so we need to round the 6 to a 7, and we're going to drop, all of this gets dropped. Okay, and so we go 3.27. There it is. Okay, well, let's try another one. How about 1 times 4? Whoops, let's not do 1. Let's do 3 times 4.42. And I put that in my calculator, and what do I get here? I get 3 times 4.42, and that is 13.26 for a calculator answer. Remember, when we're doing significant figures, we're doing it on the calculator answer. And we're trying to get the calculator answer to make sense with the significant figures that we put into it. The whole purpose of significant figures is to correct the calculator answer. And so we take a look at this and we go 1 sig fig. There's just 1. And we have 3 over here. And what's the least between 1 and 3? That's 1. So we want our answer to be 1 SF. This is what we want. And so we do the same thing as we did to the rest of them. We start counting. We go 1. Well, that's it. That's our number. And so we're going to look one more over and round. 3 is 4 or less, so we're going to not round it up. And so it's going to be, let me change colors here. So it's going to be 1. Now remember, we have to keep it the same size. 13 and 1 is not the same size. 13 is 10 times bigger. So we have to add a placeholder 0 to keep it the same size. That's a placeholder. So now 13 and 10 are the same size. And so since this is a trailing 0, as I discussed in my previous video, that's a trailing with no decimal. It's not significant. That 0 is not significant. So this, sure enough, would be 1 SF as our answer. So our answer is 10. That's 1 SF. And our calculator answer was 13.26. Now, what do you do if you have a calculation where you know that it's supposed to be, let's see, that you know that it's supposed to be a certain number of sig figs, but it doesn't look that way? How about if we had, say, let's see, 45.69. Let's say if we had 45.70 times 23. And I put that in my calculator, 45.70 times 23. And I get 10,051.1. Okay, and I'm going to go ahead and round this. And so I get, let's see, this is going to be 4SF, 2SF. So I'm going to want this to be 2SF. So I go 1, 2, I look one more over, and that would make this 11,000 with its placeholders. When you're rounding like this, you need to ignore the decimal. It doesn't matter. If you need a decimal, you're going to have a decimal. If you don't need a decimal, you don't need a decimal. And these are trailing. And so without a decimal, with no decimal. So sure enough, this is 2SF. How about if we had another one? Let's say we did 45 times 23. Let's see what would happen with that. 45 times 23. Yeah, there we go. How about if we had 45 times 22.99. All right, and I'm going to put that in my calculator. And I get a calculator answer of 1,034.55. All right, so let's go ahead and see if we can round this. And we say this is 2SF, this is 4SF, and we want 2SF because rules for multiplication and division is least number of significant figures. And so let's go ahead and do that. Let's see what happens here. So I go 1, 2, I look one more over. That's 4 or less, and we'll turn that, not going to round that up. And so we end up with 1, 0. Now I have to add in those placeholders. And I say, hey, look, I'm done. But wait, there's a problem here. If you look, you will see that all 3 of these zeros are trailing. There's no decimal, which means that this should be 1SF as written. So what are we going to do? We can't just write down 1,000 because that's 1SF. There's 3 trailing zeros. Trailing zeros without a decimal are not significant. So what if I was to write down, let's just add a decimal. Now these are still trailing. So what do we have here? It's trailing with a decimal, so this is 4SF because it would be 1, 2, 3, 4. You have a decimal. You do have a decimal. Right there, I just put it in. Okay, so it's still not what we want, which is 2SF, because that's what we want from up top. You got 2SF times 4SF. You should have 2 significant figures in your answer. So now what do we do? So what we do, if we can't put it in a form that makes sense, just like what we just did, what you have to do is you have to put it in scientific notation. Scientific notation is going to be automatically all significant. So let's put that number in scientific notation. So I'm going to copy it down from up above. So we're going to put it in scientific notation. Matter of fact, on the next lab, one of the calculations you do is going to look exactly like this, where you're going to get a number that looks like 1034.55, and you're going to want 2 significant figures, but you can't do it. Not like what I just showed you there, but you can put it in scientific notation. So how are we going to put it in scientific notations? What's step one? If y'all remember, times 10, we're going to count once, twice, 3 times. We're going to move that decimal place 3 times, so that's times 10 to the third. And then we're going to count back. Now we're going to go back and we're going to say 1, 2. And so since the decimal is now there, we're going to say 1.0. Now, this right here, the 1.0, if you look at it, this is right here. This part right here has a trailing 0 with the decimal. All scientific notation has a decimal, and if it has a 0, it's always going to be significant. And so this is trailing. This is a trailing 0 here, but you do have a decimal in scientific notation, and therefore now we finally have 2 significant figures. So the take home on this is, if you have to put it in, if you need to, you can always put it in scientific notation, as long as however many digits you have in the number portion, that will allow you to have the right number of significant figures. So if you look all the way to the top up here, 1034.55, and you look at the problem, the original problem, we have 2 sig figs, 4 sig figs, and we need 2 sig figs. The only way to get it in 2 sig figs is to go with scientific notation. Now, the second rule for significant figures is for addition and subtraction. And the rule for that is we round to least decimals. Now, it's really important to realize with addition and subtraction that you do not use sig figs, do not use significant figures. Do not use sig figs of the numbers, okay? We're going by least number of decimal places, okay? Least number of decimal places. So if you had, say, 42.1 plus 16.29, we put that in our calculator, and we're going to get a calculator answer. And this is the whole point of sig figs, is to correct our calculator answer. So we say 42.1 plus 16.29, and I get a calculator answer of 58.69. That's my calculator answer. So since we're doing addition or subtraction, in this case we're doing addition, we have to look and see how many decimal places we have, how many decimals. So I look here, that's 1 decimal place. And I look here, and that's 2 decimal places. So the least number of decimal places, this is the least, is 1 decimal place. So what we want, so we're going to want 1 decimal. Notice I did not say anything about how many sig figs each answer had. Now, we look over here and we're going to do the same thing. We have 6. There's our 1 decimal. We're going to look one more over, and we're going to round. And so we're going to round the 9. And so if we do that, we're going to round that 6 to a 7, and that becomes 58.7. Okay? And so if we look at it, we now have 1 decimal. And you may say to yourself, well, but wait, Mr. Pierce, the 42.1, that was 3 sig figs, 16.29, that was 4 sig figs, and well, I should have 3 sig figs in my answer. Well, that's just a coincidence. That's just a coincidence. That's just how it worked. I mean, I could make these problems so it doesn't work out that way. So let's do another one. Let me show you. How about we do, let's say, 12 minus 1.29. Okay? And this is subtraction, so we're going to go by rules of addition and subtraction. Means we go by least number of decimals. And I go 12 minus 1.29. And I get a calculator answer of 10.71. All right? Now, we have to go by the least number of decimals. Now, I look here at the 12, and we have 0 decimal. You know, 0 is a number. You can have no numbers past the decimal, and 12 has no numbers past the decimal. And in this case right here, 1.29, we have 2. And so we want our answer to have no decimals. And so we're going to do the same thing that we've done all the other rounding. We start with the last number we want, which is the 0. We look one more over, and we round up. That 7 is going to round that 0 up to a 1. So there's our answer. Our answer is 11, which has 0 decimals. So, you got to keep in mind, it is possible to have no numbers past the decimal. If you have no numbers past the decimal, well, that's 0. And so if it's the least one, well, then you should have that in your answer. So that's how you do significant figures with addition and subtraction. Okay. So let's switch gears completely here, and let's start doing some conversions. So the first thing we have for conversions is you will have these equalities. Now, when we do conversions you're going to do when you do nurse math. If you do get in a nursing school, or if you go on to some sort of allied health professional, you may have to do what's called drug calculations or nurse math. And nurse math is all about conversions. That's what it's all about. And so the first thing you have is you have these things called equalities, and they might look like something like this, and that is that 12 inches equals a foot. And you might and this is an equality. This tells you that for every foot you have 12 inches, and for every 12 inches you have a foot. And so what we have to do with these equalities, because you can't use this like it is you have to put them into conversion factors. And so the conversion factor would look like this: 12 inches to a foot. And it's implied that there's a 1 here. 12 inches to a foot. Or you can write this out as 1 foot to 12 inches. These, when they're written out this way, is a conversion factor. Now, we can't use the equalities for pretty much anything, but conversion factors are what we're going to end up using. We're going to end up using the conversion factors to set up our problems. And so when you have a conversion factor, what it's telling you is for every 12 inches, I can get a foot. For every foot, I can get 12 inches. These conversion factors are actually fractions. They're just a fraction. That's all they are. No different from saying 2/3 or quarter or 5/4 or whatever. They're fractions. That's what they are. And so we can do things like this. We can say, well, how many feet is 176 inches? Okay. So this is our first conversion. So we got to try to decide, well, how many feet is 176 inches? Okay. Now, I'm going to show you how to set this up. Whatever you do not think in terms of whether I'm going to divide or whether I'm going to multiply or whatever. And you may know how to do this just by saying, well, you know what, I know I can just divide it, but that's not how you do these. Okay. So what we're going to do is we're going to set this up in a big fraction, a conversion problem. Okay. So step one is you go through and you pull out everything that you need. So I have feet and inches. So I'm trying to go from inches to feet. All right. And so I need a conversion to go from inches to feet. And we do. We have it. It's right here. Okay. It's right there. That's those guys. And the other thing that we have to do is, what is my measured number? Now, your measured number is whatever you measured. And it's not the conversions, but it's definitely whatever you measured. So the 176 inches, that's your measured number. And you need to go through this process with everything. You don't ever just jump straight to the setup. I have my measured number, I have my conversion. So now I'm ready. So step one, you draw a line. Step two, you draw another line. And so the first thing you do is your measured number always goes right here. Okay, we always put our measured number in that upper left-hand corner, and nothing ever goes here on the bottom left. If you start to put something on that bottom left, you're probably starting with the conversion factor. Always start with your measured number. So what's my measured number? It's 176 inches. So I'm going to put that down there. And I'm going to make sure that I always am using units. What's my unit? Inches, right? Now, the next step is that inches have to end up over here. The reason is because every time it's one over the other, they're going to cancel. And so where do we have inches on the bottom? We have inches on the bottom over here. Now, we don't have to have both those conversion factors. I could have just easily taken, and we will, taken this and flipped it over because that's how I got the second one anyway. And so we copy down what we have. And so we do that and we get 12 inches for every 1 foot. Now, we have to look at this and we have to decide what cancels. And the way we cancel is if it's across from each other, see the green arrow, if they're diagonal, inches cancel, we're left with feet, which is what we want. And now we can put it in a calculator. And since it's a fraction, everything on the top is divided by everything on the bottom. So we go 176 divided by 12, and I get a calculator answer. I get a calculator answer of 14.66666 and a bunch of others. Now let's not forget about this unit here. The feet is what's left over, always using units. So let's go ahead and fix this for significant figures. And we go over here and we say, well, 176 has 3 significant figures, and a 12 inches to a foot, that's defined, so it doesn't count because that's a conversion. That's a defined conversion. And so our answer should be 3 significant figures, and we're going to count across. We're going to go 1, 2, 3. We're going to look one more over. 6 rounds up, and so we have 14.7 feet. And that's our answer with the correct number of sig figs. Okay, we're going to do this in lab 1, by the way, as part of our conversions. All right, so let's do another one. All right, so let's see. How about we have that we know that, let's see, how many centimeters is a 71.5 inch person? Okay, how many centimeters is that? And so, first off, we have to look up in our textbook or wherever we need to, or we just remember the relationship between inches and centimeters. And I happen to look it up, and it is 2.54 centimeters equals an inch. Now remember, that's an equality, so we're not going to be able to use that as a conversion, but we can write out the conversion, and that's you just make a fraction and you say for every inch you have 2.54 centimeters. So I just took that equality and turned it into my conversion factor, which is something over something. So there it is. All right, so I have my conversion between inches and centimeters. And what's my measured number? Well, my measured number is the 71.5 inches. That's what I measured. I took my patient and I measured their height. All right, that's my measured number. All right, so I have everything I need to do my one conversion. So what are we going to do here? So what I'm going to do is I'm going to draw a line. Always start with drawing a line. I'll draw another line. And I always start with my measured number, 71.5 inches. Okay. Remember, and I'm just putting a red X here just to emphasize nothing ever goes there. Nothing ever goes there. We always start with our measured number. All right. Need to correct that. I always start with my measured number. And so now I need to have what down here? I need to have inches because they need to be diagonal to each other so that they will cancel in the end. Anything that's across from each other like that, top to bottom, is going to cancel. And so this inch to centimeters up here in blue, I'm going to have to flip it over. Okay. And so if I flip it over, that puts inch on the bottom, and it puts the 2.54 centimeters on the top. All right, y'all see how I did that? You know, I just copied it down, but I put it over the top. I had to flip it over. That's to get the inches to cancel. And so if you do that, now inches cancel, you're left with centimeters. What are we looking for? Centimeters. Okay, now we can put it in the calculator. 71.5 times 2.54. And I get a calculator answer, 181.61. All right, let me make that 8 look a little better. 181.61. And don't forget your unit. Units, whatever's left over ends up becoming your unit. And now we need to fix it for sig figs. And so we look over here and I see this is 3SF. We got 3SF. Our answer should be 3SF. And so I count across and I go 1, 2, 3. We'll look one more over, and that 6 is going to round up. And so our final answer is 182 centimeters. 182 centimeters. Okay, so that's my final answer there. Now, you can have a situation where you have to use more than one conversion, and that happens all the time in nurse math. But let me show you another one before we get into nurse math. And so it looks like this. So how many inches is 1.58 meter? Okay, now we can find a conversion to go directly from inches to meters, but it just so happens that I remember, and this is how we do these, there's actually more than one way to do these, that 2.54 centimeters from my previous problem is the same as an inch. And if I remember my metric relationships, I know that there are 100 centimeters for every meter. 100 centimeters equals a meter. There's my conversion. We got 2.54 centimeters is an inch. And I want to go from meters. I want to go between meters and inches. That's what I'm trying to do here. All right. And I've decided that the 1.58, that must be my measured number. And I have two conversion factors now. So what do we do here? So we'll draw a line a little bit longer. We'll draw another line. We always start with my measured number. Well, that's 1.58 meters. Okay. And now what we have to do is we have to be able to match. You have to match. Match units. That's what we're going to do. And so what do we have to match? Well, we have to match one at a time. So what has to go over here? We have to have the meter, right? Where do we have the meter? It's right here. Okay? So I know there's no meter over on the 2.54 centimeters inch. There's only one conversion factor actually has the meters in it. And so I see that it's the right hand one to 100 centimeters per meter. The meter's already on the bottom, so I don't have to flip it over. So I'm going to pull it down. So this is 100 centimeters for every meter. I draw a line. Now, when I use a conversion factor, what I should do is go ahead and check mark it. Put a check mark by it. Okay, that's to keep you from reusing the conversion factor, because if you reuse it, you'll just go back in the other direction. Okay, am I done now? Well, I'm looking for inches. I'm not looking for centimeters, because if I stopped right now, meters cancel. I would be left with centimeters. So what's next? Well, once again, we have to match. We go centimeters, has to end up over here, okay, to get it to cancel. This is matching. Once you have all your conversion factors, all you have to do is match. And so what do we have up here that has centimeters in it? Here it is, right over here. We have centimeters. Except this time, we're going to have to take this, and we're going to have to flip the conversion factor over. There we go. So we're flipping it to get centimeters on the bottom. Now make sure that 2.54 stays with the centimeters. And so the 2.54 comes down with the centimeters, and the inches goes up top. And so once we use our conversion, because we're going to be doing conversions where we have 3 or 4 conversions with nurse math, and there it is. Okay, we used up both our conversions, and now what? Centimeters cancels. And we're left with what? Inches. Now we can go ahead and put this in our calculator, and what we do is we multiply everything on the top and then divide by everything on the bottom. So I'm going to put this in my calculator, and I go 1.58 times 100 divided by 2.54. So everything on the top times each other divided by everything on the bottom. There's only one thing on the bottom this time. And I put that in my calculator, and I get a calculator answer. 60.60, and we'll just write, I'm not going to write them all down, but 62.205 is my calculator answer. Let's not forget my units. And we want, let's see, we got 3SF. This is defined. There's 100 centimeters per minute. That's defined. And we have 3 there. And so we go 1, 2, 3. 0 is 4 or less. And so we're going to get 62.2 centimeters. All right. Okay. Now, that's how you would set up if you had more than one conversion factor. Now, nurse math or dosage calculations is using more than one conversion. So let me show you how that works. We'll go ahead and start doing some nurse math. Nurse math is fun. It's also quite useful. All right, so let's set up a nurse math problem. So let's say a 8.6 pound baby. Okay, so we have an 8.6 pound baby, needs a drug that has a dosage of 12.5 milligrams per kilogram. And if it comes as 25 milligrams per tablet, how many tablets are you going to give this baby? All right, now, everything up here is either a measured number or some sort of conversion. Now, the one thing that you always need for these calculations, and this is something you should probably memorize, is that there's 2.20 pounds per kilogram. You're always going to need that. It's hardly ever going to be given to you, but drug calculations are always in terms of kilograms of body mass. But when you weigh a baby or a person, you measure them in pounds. That's how you do that. So you're always going to need that particular conversion. Now, the next thing you need to do is go ahead and pull down all the conversions. Now, anytime you have something to something, that means that's a conversion. So the thing to do is just to go ahead and copy them down, but copy them down as conversions. So we have 12.5 milligrams for every kilogram for the first one I underlined, and then you have 25 milligrams for every tablet. And I don't see anything else up there that has dosage requirements, okay? So we have the first one, which is our pounds to kilograms. Then we have the second one, which tells us the dosage. And then the third one tells us, well, what does it come in? All right. And we have our measured number up top. This is measured. It's almost always how much the patient weighs. And so this time we're going to just draw a long line, a little bit longer than usual. All right. We're going to draw another line. Okay. We always start with the measured number. What's the measured number? It's 8.6 pounds. And now we need to match. How do we match? Well, the first thing we need is what? Pounds. Where do I see pounds up here? I see pounds right there. And so this is going to have to be flipped to get pounds on the bottom. And so now I can put down 2.20 pounds for every kilograms. So this guy ended up over here. We draw another line. And I know I'm set up so far right because pounds cancel. They should cancel if you matched. So what's up next? We have kilograms. Where do I see kilograms? Right here. See? I see kilograms. And kilograms is already on the bottom because where do we need kilograms to end up being? We need to have kilograms needs to end up across from that kilograms. And so we just go ahead and copy it down, and we have 12.5 milligrams for every kilogram. Now remember, as we go, we need to check mark as we go. So we use the first one, we use the second one, okay? Now what do we need? Well, I see milligrams. Where do we see milligrams? I see milligrams right there. And I need milligrams. How do I know I need milligrams? Because I need milligrams to come down here. So it'll be across, so it will cancel. Okay? And so it looks like I'm going to have to flip this to get milligrams on the bottom. And so it is, we bring this on over here. So it's going to end up being 25 milligrams on the bottom. And your tablets on the top. And we go ahead and make sure everything cancels. And so sure enough, kilograms cancels kilograms, milligrams cancels milligrams, and we're left with tablets, which is exactly what we need. And so we look up there and check mark that. And the question asked, well, how many tablets? And that's what we're left with. So let's go ahead and put this in our calculator. So everything on the top divided by everything on the bottom. Now, when we do the division, I want you to make sure you put everything on the bottom in parentheses, okay? And so you should check this out on your calculator too. So we go 8.6 times 12.5 divided by parentheses 2.2 times 25, close parentheses, and we get 1.9545 tablets. And we're going to round that, and we go back here and we say we have 2 sig figs, 3, 3, and 2. Tablets is counted. You have to count out tablets. That's 2 sig figs, so we go 1, 2. We look one more over. We're going to round that 9 to a 10, and so that makes this 2.0 tablets. So we go over to the pharmacist, we get 2 tablets, and we give it to the baby. And there you go. So you have 2 tablets. The bottom line with doing these things is you always start with the measured number. You pull down your dosages and the form it comes in, or whatever conversion factors you need, and then you start matching. If you can match, you can do this. You can make these things 5, 6 conversion factors long, but you're only doing it one at a time. Each conversion factor is only one at a time. You're matching, matching, matching. Make sure everything cancels. Put it in your calculator, and you're done. And that's how you do that. So next time we will do some more nurse math, and we'll practice. And you should go through the textbook, and you should be doing the problems in your study pathway, and you should be doing extra problems. You do as many problems as you can. Do the red ones, then do the black ones, because the red ones are in the book.